Hello everybody, I'm Storm here. Welcome back to Kerbal Space program. In the last episode, we were able to rendezvous the Duna lander back with the longbow, and then perform a flyby of Ike to gather a little bit more science, and also use Ike as a gravity assist to eject us from Duna, and then worked on getting back to Kerbin, which we were able to fly the longbow back to Kerbin, and park that back into orbit of Kerbin, and then return our Kerbals with all of the science back home, which we were able to do right at the end of the episode, and brought back a giant pile of science. So, after the episode, what I went ahead and did is I ran a bunch more Moon and Minmus landing missions, because, we've done that already a couple of times on screen, so I went ahead and just kind of landed a whole bunch more missions in different biomes on Minmus and the Moon to gather a bunch more science, and as you can see, we're up to now the 6309.8 science available. So it was quite lucrative for science. Didn't design any new ships, just used the same ones that we've used before. Just kept flying basically the same mission over and over and over again, just landing in different spots to gather, science from different different areas. I think I still have 2 or 3 more biomes on the Moon that I haven't gotten to yet, so there's probably another 1,000 to 1,500 science that I could potentially get from the Moon with the science experiments that I currently have. So maybe I'll do some more of that, but again, that's all gonna be off screen because we've done that before. I don't think there's any reason to show it. So, what we're going to be doing today is we're going to be unlocking some new tech, which I've kind of planned that out a little bit, so I pretty much know what I'm going for to some point. And one thing I noticed is I ran through our transfer window planner and noticed that we have an open transfer window to Joule. So, I don't think I'm ready to try to send a manned mission out to Joule just yet, but we could send an unmanned vehicle, so that's probably what we're going to go ahead and do. We're going to unlock a bunch of new tech, and then we're going to use an unmanned vehicle to test that new tech out as we fly out to Joule. There also is another unmanned mission that I want to try, but that one's not time sensitive. This one is, so we need to get this one done now. Alright, so, into the Science Center here. What we're going to go ahead and do is there's 2 primary techs that I want to unlock. I want to go for ion propulsion, get that. Advanced ion propulsion, get that. And then plasma propulsion, and get that. And that is going to unlock the magnetoplasma dynamic thrusters, which are probably some of my favorite engine types that you can mod in. I think these are from the Real Future Propulsion mod. I think that's where these are from. They're great. They have extremely high specific impulse, 3,000 specific impulse, 3,000 seconds in vacuum, and they have pretty decent thrust as well. Because your ion engines, if we go back and look at our ion engines, they have really good specific impulse as well. This is a 3690 seconds here, but thrust is really low. 1 kilonewton of thrust off of this ion thruster, which is actually probably unrealistically high for what an ion thruster can actually do. But these magnetoplasma dynamic thrusters, this one has 96.4 kilonewtons of thrust, right? So they have the perfect combination of high specific impulse and high thrust. And these are actually real engines. I believe that Japan launched an experiment to test the concept in space, because they really only work in a vacuum. And proved that this type of engine will work. I did look up how this actually works. But I can't remember. I'd have to look it up again, and didn't do it before the episode. The big problem with the magnetoplasma dynamic thrusters is that they require an enormous amount of power in order to operate. So much power, in fact, that in order to practically use them, you would need to basically have to power them with a nuclear reactor. And so that's what we're going to do. We're going for nuclear power. And we're going for the improved nuclear power as well. Done. Okay. Which, you know, in the real world, it isn't practical or really safe to attempt to strap a miniaturized nuclear reactor on top of a rocket. I don't think we can make one small enough that would fit on top of any available rockets these days. And they are incredibly heavy. So I don't know if we have any rocket that would be capable of getting one into orbit. So that's kind of the sticking point with those magnetoplasma dynamic thrusters right now. If you can sort out the power problems, they're great. Alright, so also I want to get advanced solar technology, which is going to get some new solar panels available. Research those. Good. And we're also going to need some better heat management, because that's also a big problem with nuclear reactors, as they get very hot. And you don't really have the opportunity to bring a lot of coolant, so you're going to have to use radiators. And I did get a new radiator mod. I forget the name of the mod off the top of my head. We're going to go ahead and unlock that, and we're going to go ahead and get the advanced heat management, because I'm going to need these high temperature heat radiators. Done. Okay, that leaves us with 1100 science to get something else with. And I'm not entirely sure what I want to go with. I go with 2 550s or 1 1000. This will get us a new science experiment, the negative gravioli detector. Plus a bunch of other stuff in here. Cryogenic gas separators, convertitrons, mining excavators. This is going to be necessary for our resourcing operation that I want to put on the moon. So we definitely going to want this sooner rather than later. So let's go ahead and grab it. 599.8. We have the option for hydroponics, which is also going to be necessary for longer range manned missions. Or I could get nuclear fuel systems to increase the lifespan of our reactors. That's going to be necessary if we want longer range, longer endurance vehicles that use reactors, nuclear reactors. So I might go for that later. And I also really want to get this stuff, the Advanced Metalworks and the nano lathing. High performance fuel systems would also be nice for better tanks. Bigger, better tanks. I think I'm going to hold off just yet until something kind of jumps out at me that I really need. We'll go with this for now. This is going to be more than enough of the technology that I need to get this probe launched. Oh, actually, no. I did actually need one other thing. I forgot. Because there was one other thing I wanted. And it was that Advanced Metalworks. That is what I wanted. Yes. I kind of already planned that out a little bit and forgot that that was part of the plan. So we have 300 more science, 299.8. So that's enough to unlock another couple of techs or so, but some of the lower level stuff. But I think I'll hold off on that for now. Alright, so with that done, we're going to go ahead and start designing this vehicle. And I'm kind of going to overbuild it a little bit. Alright, first thing we're going to want is we're going to want a nuclear reactor. And the nuclear reactor I'm going to go with is the Prometheus Fission Reactor. It produces 2,000 electric charge per second. And it has a fuel lifespan without any additional tanks of what? Estimated core life, 5 years, 12 minutes. So with the onboard storage, it'll run for 5 years before it runs out of nuclear fuel. Alright. So, we're going to need some electric storage to store the electricity. We're going to need a probe core to control it. Okay, so I think what I'm going to want to do here is I'm going to structural. I want to get one of these structural tubes. I'm just trying to see if there's anything else that I want to use. No, I think that structural tube will do it. Actually, I think I want to put a couple of those in there. I thought there was a slightly larger one of those. Maybe not. Oh well, that'll do. I'll do 2 of those. Okay, so, some batteries. Let's get in there. And let's put in a nice stack of batteries. And then, you know what I'm going to do is I'm going to throw probe core in there. I'm going to use the Octo 2, which has a better flight control system, but it does not have any reaction wheels and a very, very small onboard electric storage, which doesn't matter. We're going to be throwing a big reaction wheel on this thing eventually. Communications. I think I'm going to throw a little antenna in here, just a couple of little antennas in there, just to make sure that it has some local communication. Now, what I may actually do is make this that I'm building right now a modular propulsion unit. That we may use on a lot of different things. Yeah, that could work. Maybe even a new propulsion unit for the longbow, because it definitely needs one. Alright. So with this, what I'm going to do is I'm going to throw... some RCS tanks in here. Can I just kind of squeeze some in there? It'll be very difficult to access and refuel. If I put them in there. I could put them on the outside. I'll think about that. Alright. What we're going to do instead is we're going to go ahead and we're going to put a reaction control wheel there. And a docking port. Yes. Okay. Now, do I actually want any solar panels on this? It might be a good idea. I don't know. I'll hold off on that. Because... and I'll show that in a minute. The engines that I want to use are going to be this, the Peerless Thruster, and that requires 1,999.999 electric charge per second. This guy produces 2,000 electric charge per second. So while these engines are running, it's basically going to be using the entire capacity of the reactor to power 2 of those thrusters, and I want 2 of them. In fact, let's go ahead and put those on. I'm going to use this. No, not that. This. There. To adapt to have 2 positions for their engines. There you go. Alright. And let's see. The reason why I wanted that one structural tech is because of this. These radial stack adapters. And I want like 8 of them. I'm going to try and put as much fuel on this thing as I can. Alright. Because I don't have very large fuel tanks for the lithium fuel, because these things run on lithium that is needed here. So, lithium tank. Yeah, this is the largest lithium tank I currently have. And that provides 14,000 meters per second at delta V. But without anything else on it. Let's see, can I stack up to 2? That gives 21,251 meters per second at delta V on this vehicle. Okay. Now, it's going to need some thermal management here. And I did some testing in another save with this reactor to see exactly how much thermal management it's going to need. And we're going to need these radiators. Where do I want these radiators? They extend, but they cannot rotate. These are better, I think. Because they can extend. There you go. Yeah, that'll work. In fact, let me go ahead and put that on an action. So I'll put that on the 2 button. Toggle radiator. Okay. Done. Alright. So what I'm going to do is I'm going to reroute this part to there. Okay. Is it done, though? I think I am still going to want some solar panels. No. I'm going to need RCS. I'm going to need some RCS. Right. Let's see here. Fuel tanks. Could I potentially put a very small can I put no, cannot put RCS in that tank. Procedural RCS tank. I could throw that on there. cylinder, cone, smooth cone, polygon. No. I mean, it doesn't need to be a dome. That's way more than I think I'm gonna need. Though, you know, I could reduce the length down. I could make them cones and just make the tops really narrow and make them like that. I think that would work. Alright, what texture do I want to put on there? That's actually not bad. That's not bad. Yeah, I'll go with that. Okay, so we got some RCS on there. Don't want to put too much mass on there. Let's see, 17,000 meters per second. And I could add a whole another tank to that stack for more delta V. I mean, at some point we're overkilling here. That should be enough, I think. Alright, we now need the actual, like, RCS blocks. If I were to move these... higher up, like there. Okay. I could put RCS blocks at the top of these tank stacks and the bottom and there. Now, we can't actually do magnetoplasma dynamic RCS. But I don't want to use up the lithium fuel that we need for the actual main engines for RCS control. Especially it's going to be used sparingly. Okay. Now... what I'm going to go ahead and do is make this a sub-assembly as a plasma propulsion module. Save it. So, if I bring that out, I should be able to, yeah, use that for a bunch of different things. Okay, so this is going to be fueling our Joule expedition, and I also want it to be able to come back home. So, I am going to want it to be able to return its experiments to Kerbin. because those experiments are extremely valuable. If they're returned. Alright, so I'm going to leave that Clampetron docking port there. And what we're going to do is I'm going to put another Clampetron docking port there. And then I'm going to put a heat shield. No, I'll need a stack separator. And then a heat shield. So undock. As I'm re-entering, I'll ditch the docking port to expose the heat shield. And then we're going to have a payload bay. Alright. And I got another new mod. One that makes a miniature version of the materials science bay. So I don't have to put this giant experiment right in the middle of this thing. And I can bring a bunch of them. Okay, so what we're going to do is I'm going to put another small stack of batteries here. And another probe core, because we're going to need one, right? And we're going to need a, excuse me, a reaction control wheel. Small, there, okay. To provide control. Good. And it's going to need... Now, this bit's probably going to need some solar panels, which is fine. Alright, so now we need the science experiments. We're going to need the material science pods. I don't want to bring that many. We'll bring 4 of them. Should that be enough? Or 6? I'll bring 6. So why not? Same thing with the mystery goo containment units. We're going to bring 6 of those. Alright. Okay. And then we're going to bring our press map barometers. The seismic accelerometers we don't need because we're not going to be landing on anything here. Negative gravioli detectors. Now that's going to be going off constantly because we've never used that experiment before. We're going to do our 2 hot thermometers. Anything else that I need? No, I think that's probably it. Close that up. Alright. We're going to need some solar panels for this, which I'm going to just use the good old retractable photovoltaic cells. I'm going to put those on button 1. Toggle the solar panels. Alright, good. I'm going to need an adapter. A structural adapter to get this down to 1.25 meters. There we go. And I think we have a new parachute system that's unlocked. There. This is going to need a deorbit. How are we going to deorbit? I know how we're going to deorbit. I am going to put in a procedural RCS tank. There. Diameter 2.5 meters. Let's swap this around. You attach there. You go there. You attach there. Alright, and then we have little engines. Little engines. These guys. They can deorbit us. Perfect. Okay. Staging. That's there. That gives me how much delta V? 245 meters per second? Really? Do I need the bigger ones? I mean, I probably don't need much more than that. 315 meters per second delta V. If I get in a low enough orbit, that should be plenty to get us down from orbit. Yeah, should be fine. Okay, good. So there we are. That is our vessel that is going to Joule. And we've been going for quite some time. Alright, let's go ahead and get this thing on top of a rocket. Alright, so we're going to need to couple... And I'm going to need another one of those adapters here. Another one of these. No. There we go. Okay. And I'm probably going to want to use my 3.75 meter stuff. We're going to need a bit of fairing around this thing. So, I'm going to need that. That's my 3.5... 3 point... whatever it is. Meter... fairing base. Yes. Okay. Upper stage... and an engine. There we are. 335. Vacuum. 1200 meters per second. 1.25 thrust to weight ratio. Should be alright. Do I want to give this? Yeah, I think I probably want to give this. Some reaction wheels. Okay. Just so. Alright. Okay. 3.75 meter stack decoupler. We're going to need a big fuel tank. Big fuel tank. Not big enough. Definitely not big enough. There we go. That ought to do. And we're gonna need a big heavy engine. Big heavy engine. Bingo. Nowhere near enough delta V. Do we have a bigger? Do we have a bigger one? No, we don't. Okay. We have these. Okay. Let's see. Coupling. What's the thrust weight on that engine? 2.34. Okay, that's good. Can I put 6 of these? Can I get 6 of these? Yeah, I can fit 6 of those. Okay. What engines? These? Those. Okay. Thrust to weight. That's still not enough. So I want to get this thing to orbit before I use. Still not enough. 8 of them? When in doubt, more boosters. It fits. But still not getting the delta V numbers I want. Alright then, what if I were to replace this fuel tank with another one of these? Do I have a big cryogenic engine? I don't think I have one that matches its form factor. So silly me. There we go. Let's grab that guy and stick it on there. 0.92 thrust to weight ratio. That's not great. That's not great. Is there any other more efficient engine that I can use? Let's see. 3.75 meters. What engines do we have that are at this form factor? We have the orbital maneuvering thrusters. That's not really going to get me what I want. 340, 2,000 kilonewtons. 5,000 kilonewtons, 290. Brine or liquid fuel. What's this? 335. That might be better for the Stage 2 engine. It's a little bit more efficient and has more thrust. Whoa. 4347 meters per second. All right. Let's give it a go. Let me just check one other thing. There was another engine. Twin bore liquid fuel engine. (2,000 kilonewtons, 300 or 280). Specific impulse. 275, 1900. These are better. Than this. Even though it doesn't look quite as... Oh, the thing is, they're bumping into each other as well. So wouldn't be able to use 8. What if I were to just use 6? 6 of them. Okay. And then I were to put some cones on top that were also fuel tanks. So I know we have those procedural liquid tank cones. There you are. (4564 meters per second). All right, I think that'll do it. This thing is gonna be a beast to try to fly. All right. All right. So there we go. We have this and those fire at the same time. Then we have this and that fire at the same time. And then we have that separate and that fire. And then these separate and those fire. And then these separate and then those fire. And then we have our parachutes. Good. And we're going to need the actual fairing halves. The fairing shell here. Payload. There you are. And that's going to need to be its own thing, and I got to decide when that's going to go. Probably sometime around there. Or there. Alright, so this is going to be the Joule probe. And we're going to save. And let's launch it. And I am going to fly this by hand. I could use the Ascent guidance computer, but I'm not. I want to fly every single rocket, at least the first time, by hand. Alright, but let's just go into MechJeb and make sure that per limit Q is turned off. Or do I want to turn that on? It'll manage my throttle for me. I think that might be the only automation I put in here, is to manage the throttle to limit aerodynamic pressure. Because we're kind of on the edge of what's going to be necessary to get this thing in orbit in the first place. Alright. And I've realized I missed something. I'm going to have to go back to bring it back into the vehicle assembly building. I missed a piece. We're not going to be able to use this. I just realized I did not put a long-range antenna on here. So once it gets out of Kerbin's sphere of influence, we won't be able to control it. Let's see. I'll have to go with that. Parachute. Should be alright. And the longest range antenna we have. There it is. No, see, that'll bump into everything. No, I mean, I could slip this one down here. Yeah, I want to get two on there. Alright, good. That would have been bad. That would have been bad if I had forgotten about that. Okay, there we go. Now we're ready to launch. Let's do it. Alright. Stability assist. Throttle up. And launch. Alright, throttle control. Managing my dynamic air pressure. We're going to want to start nosing over a bit harder here. Here's where we might run into trouble. Alright, we're going to want to start flattening this trajectory out. Well, maybe I had a lot more available thrust than I was anticipating. Right. Definitely want to start flattening this out. That works. All right, 100 kilometers. Once we get above the atmosphere, I'm going to deploy my solar panels and the radiators. There we go. Okay. Let's get the maneuver set up to circularize. Alright. I can't tell it to hold the node, but that's okay. Alright. RCS. Burn time is 1 minute and 1 second. We reach the node in 1 minute and 13 seconds. So at T-minus 30 seconds, we will begin second engine start. Well, actually, this is third engine start. Or eighth engine start. I guess you could call this a third stage. Go. Oh, I forgot to put a reaction wheel on this stage. That's why it's so hard to control without the RCS. Ah, well. It's fine. There we go. We are now in orbit, and I have 1,104 meters per second of delta V left in that stage. So we need to eject from Kerbal orbit, and I want to do it so that we get thrown in that direction. Okay. So I think that would be trying to burn around here. And if I do a maneuver for the amount of delta V we have left in that upper stage, which is 1,104. Actually, I can do it this way. 1,104 meters per second. We eject out there. Okay, that will get us outside the sphere of influence. And I want to do it right about there. Alright. I need to put like an unmanned probe in orbit that just has these gravioli detectors, because they are biome based. So I'll put one up here with like a dozen of them or more. I could probably gather a bunch of science. Because it's 20 science per scan, so I can get a decent amount. Alright. There we are. We are at the node in 5 minutes and 30 seconds. Where the burn is going to take 54 seconds, so that's T minus 27 seconds. We want to start the burn. Alright, let's go ahead and accelerate. Okay, let's make sure that we're on the node. And burn. Haven't even fired up those magnetoplasma dynamic engines yet. And basically, I'm just burning this thing until the fuel runs dry. And there it goes. Alright. Oh, what is that doing down there? No, 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 no. No, 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 no. You're up there. Okay. Separate. Okay. How are we doing for energy or electric charge? We're dropping a little bit, but that makes sense. Alright. If we were to warp till we got some sunlight. There we go. Electric charge is recharging. Good. Let's just point us at the sun for a second. Make sure we're getting maximum charge out of those solar panels. Good. I don't want to fire up that reactor until I absolutely have to. Actually, I'm going to go ahead and start it up real quick. And I'm looking at the core temperature, make sure that it holds steady at 850. It does. Good. Deactivate the reactor. I don't want to use up that enriched uranium if I don't have to. And that core temperature is slowly bleeding off. Okay. Let's go ahead and warp out to our sphere of influence transition. Okay, there we go. Now here is where I'm actually going to want to go ahead and run that gravity scan. I could transmit it home, but I'm not. I'm going to keep it because the thought is to bring all this home. Alright, now here is where we're going to use MechJeb. So, my orbit takes me out past Duna already. Well, past Duna's orbit. So there's Joule. Let's set it as a target. And this is just to avoid having to just mess around with maneuver nodes forever. And I want to do a bi-impulsive home and transfer. Create the node. There it is. The node is in 18 days, 2 hours, 23 minutes. And we get our encounter over there. Alright, good. The burn time is going to be 9 minutes and 7 seconds. I haven't even activated the engines yet. Activate the engines. There we go. Engines are online. Now, I have 5,610 electric charge in the batteries, which means I can run the engines for about 2 seconds. 3. No. 2.5. 2.5 seconds before we burn through our electric charge if I don't turn the reactor on. Alright, but what I might do is go ahead and end the episode here. And we'll do this burn and fly our Joule mission. Do I want to fly the whole Joule mission? Yeah. I probably will do that burn, launch a second one of these for the other mission that I want to do. And, actually, I don't know if I want to use one of these for that. I don't know. I'll have to think about it. So, yeah. Yeah, I think that's what we'll go ahead and do. We'll do that. We'll do this maneuver at the start of next episode. It's going to be 9 minutes of thrusting. Okay. I might kind of cut that a little bit, but, you know, that's what I'm going to have to do. All right, so for now, we'll stop here. So I hope you guys enjoyed it. Thanks for watching. Go ahead, like, subscribe, and comment, and I will see you next time.